Welcome to Mrs. Harmison's Chemistry Concepts Video 2 on atomic radius. By the time that you are done watching this video and practicing the concepts in it, you should be able to define atomic radius, tell how atomic radius changes as you go across the periodic table, tell how atomic radius changes as you go down the periodic table, and, when given two different elements, tell which one has the larger atomic radius. The atomic radius of an atom is the distance from the center of the nucleus to the outermost electron. Atomic radius is a periodic property, which means that the atomic radius changes in a regular way as you go across or down the periodic table. Let's examine what happens to the atomic radius as we move across the periodic table. Let's look, for example, at the elements sodium and magnesium. Magnesium has one more electron than sodium. It might seem like having more electrons would make the atom larger, but that's not actually how it works. Magnesium also has one more proton than sodium has. This means that magnesium has more positive charge in its nucleus, which pulls the negatively charged electrons closer to the nucleus, resulting in a smaller atomic radius. Therefore, as you move from left to right on the periodic table, atomic radius decreases. Now let's look at what happens to atomic radius as we move down the periodic table. Let's consider the elements sodium and potassium. Sodium's outermost electron is in the third principal energy level. Potassium's outermost electron is in the fourth principal energy level. Because each new principal energy level is further away from the nucleus than the one before it, potassium has a larger radius than sodium. As you move down the periodic table, atomic radius increases. In summary, as you move down the periodic table, atomic radius increases, and as you move across the periodic table from left to right, atomic radius decreases. In general, the largest atoms are found at the bottom left of the periodic table, and the smallest are found at the top right. Now let's practice what we've learned. Which of the following would you predict to have a larger atomic radius, silver or copper? As you can see, silver is lower on the periodic table than copper. This means that silver's outermost electron is in a higher principal energy level than copper's. This tells us that silver will have a larger atomic radius. Which would you expect to have a larger atomic radius, aluminum or chlorine? On the periodic table, chlorine is to the right of aluminum. This means that chlorine has more protons and therefore a larger amount of positive charge pulling its electrons in. This results in aluminum having a larger atomic radius. Put the following elements in order of increasing atomic radius: tungsten, zinc, barium, and bromine. In order to put the elements in order of increasing atomic radius, we need to start with the one with the smallest atomic radius. The smallest atoms are found in the top right part of the periodic table, so let's start there. If we go from the top right to the bottom left, the first element we come across is bromine, then zinc, then tungsten, then barium. The order of these elements in increasing atomic radius would go bromine, zinc, tungsten, and barium. This is the end of Mrs. Harmison's Chemistry Concepts video number 2 on atomic radius. If you are one of my students and you need help with these concepts or anything else, please come see me. I would really like to help you.